Good morning everyone and welcome back once again to our YouTube channel. Today I want us to look at the questions that I gave out from our previous class, and there were two questions. The first one was use the first principle to differentiate y is equal to s cubed plus 2x squared minus 4x minus 8, and then the second one was you prove that x is equal to negative b plus or minus b squared minus 4ac over 2a. So let's look at the first one. The question says use the first principle to differentiate. So remember, when you differentiate a function, then whatever you're looking for is the gradient function. So this question requires us to use the first principle to differentiate this. And before we look at this, in case you're watching us for the very first time, please take a second or two, click that subscribe button so that the next time we produce a video like this, YouTube will automatically notify you. So before we look at this question, there's some principle that you need to know. Is identity of expansion. Identity of expansion. So you need to know the identity of the expansion, because we're going to use that identities so that we apply. So identities, we can talk about the identities of expansion. So the first identity of expansion is that when you have a plus b, then square. You see, this one simply means a multiplied by b, a plus b, a plus b multiplied by a plus b. That's what it means. So if you want to expand that using the identity, then simply means that you square the first part of it, which is a squared, then the middle part of it, you multiply a, multiply b, then you multiply by 2. That gives us 2ab, then you square the last part. That is the first identity of expansion. Second one is now when you have a negative, then the same thing, but now this one becomes a negative, because a multiplied by negative b multiplied by 2 becomes negative 2ab, then negative b squared, which is the last part, we get b squared. Then the last one is when you have a plus b, then you multiply by the same, but now with a negative sign, then you have a squared minus b squared. So this one is called difference of two squares. Class, I hope you are with me. Difference of two squares. So these are the three identities of expansion that you need to know before we look at that question. So let's proceed. So if we want to use the first principle to differentiate that, remember, we know that the dy over dx over a linear question is just changing y over changing x if it is a linear equation. And also, so we know that when you have a Cartesian plane, maybe a graph like that, let's just sketch it. It's going to cut 3 times because it's a cubic equation. So whatever is changing is y and x. That is what we have changes. So we call them the variables. So the variables that we have there are only 2, which is x and y. So the first step is to give it any change, x and y, give it a change, add some changes. So you will call this one to be equation 1. So our equation 2, add the changes. in both sides. So it's going to be y plus change in y. Just add any change. Be attentive, class. Add any change. X also, because it's variable, so we have x plus change in x, then it is cubed, plus 2, x change in x, then it is squared, minus 4, x plus change in x, minus 8. That is now our equation 2. So this question is the question when now the changes have taken place. When the changes have taken place. So can we expand? Now I want us to take this and expand. So if you have x plus change in x cube, let's expand it manually. By square first, and then we are going to multiply again by x plus change in x. So if you have x plus change in x squared first, so what are we going to have? Use the identity, the first identity of expansion. We have x squared plus 2x change in x plus change in x squared. Then again we multiply by x plus change in x, so that we get the x plus change in x cube. So multiply everything by x. We have x cubed plus 2x squared change in x plus x change in x squared plus multiply by change in x everywhere with everything, and we have x squared change in x, then we have plus 2x change in x squared plus change in x cube. I hope you are with me, class. Cube. So this means this one is expansion only of x plus change in x cube. So can we collect the like terms? You can see we have 2x squared change in x and x squared change in x. So we are going to collect the like terms there. Then also we have x change in x squared here and 2x change of x squared there. So let's collect the like terms. So we are going to have x cubed plus 2x squared change in x plus x squared change in x, we get 3x squared change in x plus x change in x squared plus 2x change in x squared, we get 3x change in x squared, then plus change in x cubed. So this one is only this. So can we expand that one again? Can we expand this again? So this one also is plus 2. Can we use the first identity of expansion? We have x squared plus 2x change in x plus change in x squared. Multiply by 2. Multiply by 2. So we are going to get, let's just repeat, x cubed plus 3x squared change in x plus 3x change in x squared plus change in x cubed plus, open up the bracket there, we have 2x squared plus 4x change in x plus 2 change in x squared. So check if maybe you can collect the like terms. Do we have x cubed somewhere? We don't have. Do we have 3x squared change in x? Any x squared change in x? We don't have. 3x, any change in x squared? Do we have? Yeah, change in x, but this is a number. This is has got unknown, so it cannot be. Then minus this. So can we now put it there? Open up the bracket by negative 4. So we have negative 4x minus 4 change x minus 8. So this is our equation 2. Once again, you can check if there is something that you can cancel out. We have negative 4x, we don't have here. We have negative 4 change in x. Do we have any change in x which is a number? We don't have. So this is when there is changes, which is now our equation 2. So we want now to get that change which has taken place. So that means we are going to subtract the original equation from this. So subtract everything. So we're going to have y plus change in y minus initial equation, which is y, is equal to, just repeat that, this x cubed plus 3x squared change in x plus 3x change in x squared, just repeat, plus change in x cubed plus 2x squared plus 4x change in x plus 2 change in x squared minus 4x minus 4 change in x minus 8, then minus our initial equation, which is x cubed plus 2x squared plus 2x squared minus 4x minus 8 minus 8. So when you open up the bracket here, you are going to get minus x cubed minus 2x plus 4x plus 8. So the sign changes. So which one can go? So you can see this one goes with that. X cube goes with x cube. Be attentive, class. Then 2x squared. Actually, this is x squared, class, sorry. Then negative 2x also goes with squared, goes with that. Then 4x also go with that. Then negative 8 also go with that. So what we are remaining with is change in y is equal to 3x squared change in x plus 3x change in x squared plus change in x cubed plus 4x change in x plus 2 change in x squared minus 4 change in x, that one. So this is the dy. But now we know that for us to get the gradient function is the dy over dx. That is now the gradient function, dy over dx. Then means I'm going to divide everything by dx so that I get the gradient function, which is dy over dx. So divide everything with the dx, and dx, class. I hope you're with me. So we have 3x squared plus 3x change in x. This one dx, one dx will go, so we remain with the dx squared plus 4x plus 2 dx minus 4. So this is the dy over dx. That is dy over dx. Dy over dx is that. So let me just repeat it here. Dy over dx is equal to 3x squared plus 3x change in x plus dx squared plus 4x plus 2 dx minus 4. So I want you now to pay attention, class, here. So that change that we are saying, let's say that now the dx is changing, it becoming smaller, and and smallest. So that means if it is coming smaller until it reaches 0, so dy over dx will be what? So where there's dx, in this equation change here, put 0. So we have dy over dx is going to be 3x squared plus 3x 0 plus 0 squared plus 4x plus 2 is 0 minus 4. So what do we have? Dy over dx will be 3x squared plus 4x minus 4, and that we have differentiated from the first principle. So the dy over dx is 3x squared plus 4x minus 4. And you can even prove it here that if you have the normal differentiation, the process that we normally follow when we differentiate a polynomial, then you just take the dy over dx is going to be the other side, that is 2x, this is cube, so we have 3x squared minus, plus 4x minus 4. You see, we are correct. So that is what is here, but we don't differentiate a constant because it doesn't change. So it doesn't have a change, so we don't differentiate a constant. So class, I hope you're okay. You give me a comment on that comment section in case if there is any question concerning that. Let's go to number 2. Let's go to number 2 very fast. Let's go to number 2 very fast. Let's look at number 2. Mathematics is very sweet. And you know mathematics is everywhere. You know, even if you're doing, there is no any course that you will do without maths in it. It's very difficult for you to get a course without any mathematics in it. So number 2 was that if you given the quadratic expression or equation is equal to 0, so we ask that prove or make x the subject. Prove that x is equal to negative b plus or minus b squared minus 4ac all over 2a. So this is the quadratic formula. Remember, that's the quadratic formula. You can also use that formula to solve any quadratic equations. So we want to get x, make x the subject from that initial equation. So if you have, I want you class also to pay attention here. So when you are given such equation, the first step that you're supposed to know or to apply is to divide both sides by the coefficients of x squared, so that the coefficients of x squared must be 1. So the first step is to divide everything here by a, by a, by a. So we get x squared plus b over a x plus c over a is equal to 0. Then the second step is to take the c part of it, the other side, so that you have x squared plus b over ax is equal to negative c over a. But now, can you now complete the square? Complete the square, because there is a part here which is missing. So can you add that part which is missing, k? And when you add a number this side, you must add it also the other side. But now, if you want to we complete the square, that means this part of it now here is perfect. And for example, if you have a perfect square, x squared plus 6x plus 9, this is a perfect square. How do you factorize it? You only take the square root of the first part, then you look at the sign. If it is all positive, you put a positive. Then don't bother about that. Take the square root of the last part, which is c. With the square root of 9 is 3. Then you just square. So if it is perfect, that's how we factorize a perfect square. So that means for us to get k here, then it is going to be b over 2a squared. For example, for me to get this part here, For me to get 9 here, you only take the coefficient of x, which is 6, you divide by 2, then you square. You are going to get the value of c, which is 9. So k, we have gotten k. So here we have x squared plus b over ax plus constant. Expand that, we have b squared minus 4a squared is equal to negative c over a plus k, which is again b squared over 4a squared. I hope you're with me, class, you're following. So since now it is perfect, so how can we factorize this side? If it is, I've just explained how now you can factorize. If it is perfect, you only take the square root of this one, which is x, plus the square root of the last part, which is b over 2a. Then you square is equal to negative c over a plus b squared over 4a squared. So can we combine that? What is the LCM? Is 4a squared. A goes there, 4a, so we get minus 4ac plus b squared is equal to this x plus b over 2a squared. So for you to remove the square sign, you get the square root of both sides. You get the square root of both sides. So if you get the square root of both sides, then you are going to have, before we get to that, can we now put that one well? So we have x plus b over 2a squared is equal to, start with the b squared, minus 4ac over 4a squared. So remove the square sign, we get the square root of both sides. So we are going to have x plus b over 2a, get the square root of both sides. This side the square will go. We remain with the square root of b squared minus 4ac over 4a squared. But now we can get the square root of the denominator here. So x plus b over 2a is equal to square root of the upper part, which is the numerator, over, what is the square root of the denominator? 4a. So can we now get x? X will be, but remember, a square root of a number is a plus or a minus. So for example, the square root of 64 is either negative 8 or 8. It's a plus or a minus. So x squared is going to be negative b over 2a plus or minus square root of b squared minus 4ac over 4a. It has already started. It is featuring. The answer is coming out, as you can see. So can we now combine this? What is the LCM? LCM is 4a. 2 goes there. Sorry, class. Sorry. The square root of 4a squared is 2a, not 4. That is 2a. Sorry for that. Is 2a. Sorry for that. It is 2a. The square root of 4a squared is 2a. So combine this. LCM is 2a. So x will be, goes here, negative b plus or minus square root of b squared minus 4ac. So when you combine that, you get that. And you can see we have proved that x is equal to negative b plus or minus the root of b squared minus 4ac over 2a. So in case you have a question, just comment on that comment section so that I'll see, so that our next class we shall look at it. Your comment on our next class. Thank you so much for listening to me, and may you have a nice day.